Okay, so let's consider our stakes. Let's get a highlighter there. What are our stakes? They're advertised as being a minimum of 1 metre long. The lengths are normally distributed with a mean of 1.015 and a standard deviation of 0.01. Okay, let's aim to go 4 decimal places all throughout. All right. If we get one stake, what is the probability that it is longer than 1.025? So clearly, our stake is normally distributed with a mean and a standard deviation is given. Just a reminder, boys, that that's our 1 mark there. That's our 1 mark method mark. That's you identifying that it's a normal distribution with certain features. Even though it says it in the question, that's worth more marks than writing out the calculator syntax, all right? But having said that, L is greater than 1.025, 1.025 to infinity, mean standard deviation as given, we get 0.1587, all right? Shorter than 1.04, given that it is longer than 1.025, so that's our conditional probability, all right? And we know the conditional probability is the intersection of the two. And so what interval of numbers satisfies both those conditions? Well, it's got to be greater than 1.025 and it has to be less than 1.04. So there's that intersection there over the probability of the second one. Use your calculator, we get 0.015245 over 0.1587. Gives us our 0.9609 to 4 decimal places. All right, you can get your money back if a stake is less than 1 metre long. What's the probability that a person who buys one stake is eligible for a refund? All right, so what's the probability of a stake being less than a metre? Normal CDF from minus infinity to 1, 1.015 to 0.01 gives me 0.0668. Just remembering that even though I've got sort of minus infinity there, in reality, 0 is big enough. All you really need to make sure is that your limit, lower limit or upper limit, is a significant number of standard deviations away from the value that we're talking about. So, and obviously in this context, our stake's never going to be negative something. So you could have put 0 if you wanted to. What is the expected number of refunds? Okay, if we sell 500 stakes, well, all of a sudden that becomes a little bit binomial now. Okay, we've got a probability of a refund being 0.0668. If I have 500 trials, how many refunds do I expect? E of x is equal to NP, and I get 33.4 refunds. All right, so if a person buys 3 stakes, what is the probability they are not eligible for any refunds? So it's a genuine binomial now, isn't it? We've got 3 trials. The probability of a refund is 0.0668. What's the probability of 0 refunds? So R equal to 0. It's a binomial PDF. 3.06680 gives me 0.8127. This is probably a 2-mark question, and here is your other mark there. You've identified that this is now a binomial distribution with 3 trials and a probability of success of 0.0668. All right. Righto, a person bought 20 stakes that were of the advertised length. What is the expected number of stakes that were longer than 1.02 metres? Now, I must confess, I initially just went with x is greater than 1.02. But so it's a little tacit, little sneaky conditional, because we were told they were of the advertised length. So in other words, they were at least 1 metre. All right, so there was that little conditional part in there. All right, I must confess, first time through I didn't pick it up. So now we're looking for greater than 1.02 and greater than 1. So greater than 1.02 is the intersection over greater than 1. And if we pop that in on our calculator, we'll get our 0.33063. So the probability of any one stake being greater than 1.02, given that they are of the required length, is 0.33063. So if we bought 20 of them, well, how many would we expect? So if I bought 20 stakes, probability of 0.3, 6.61, or we would expect 7 stakes perhaps, okay, to be longer than 1.02. Finally, a new rule was introduced to find businesses that sell undersized stakes. So find if more than 5% of the stakes are found to be 10 centimetres or under the correct size. So again, I should first time through, I didn't do a diagram here. And if you do a diagram, what makes more sense? So there's my distribution. There's my mean at 1.015. And 10 centimeters under the correct size. So the correct size is 1 meter. I'm looking for 0.9. So 10 centimeters under the correct size is 0.9 of a meter. So I'm looking for the value of X, or the standard deviation, that makes this area here 5%. Yeah. So if I use my inverse norm, 0.05 on a 0-1 distribution, that gets me the Z value. So that tells me that the probability that Z is less than negative 1.644 is 5% or 0.05. So what's the standard deviation need to be to make this statement now true? The probability that X is less than 0.9 also equal to 0.05. Okay, so we know Z is equal to X minus B on sigma. Sigma is equal to X minus B on Z. My X value, 0.9, minus 1.015 over negative 1.644 gives me a standard deviation of 0.07. Okay.